Okay, so this is the answer booklet for 2.1, A Place in the Universe. The first question is on the EM spectrum. So it says, complete the table of the electromagnetic spectrum to show the positions of visible, ultraviolet and infrared radiation. Complete the sentence. So we've got the three. So they've done it in reverse. So we have radio waves here. So we've got to note that it's gone backwards. So radio waves, microwaves, then infrared, visible light, UV radiation, X-rays, and then gamma rays. Complete the sentences below by underlining the correct word with the brackets. The wavelength increases from gamma rays to radio waves. The frequency then decreases because the wavelength gets bigger. The frequency is going to decrease from gamma rays all the way down to radio waves. And the wave energy decreases from gamma rays to radio waves. These pictures of the Earth were taken using different parts of the EM spectrum. Complete the table below. So land, clouds and sea clearly seen. That's from visible light, obviously we can just see it. One side appears darker than the other, which is ultraviolet. Shows patterns of water vapour in the atmosphere that has trapped heat. So it's infrared, looking at thermal cameras, etc. Practice number 2, waves and wave speed. Waves are shown on the grid below. Write down the amplitude of the waves. So the amplitude, remember, starting from the 0 and the highest peak. So the amplitude is 15. Write down the wavelength of the wave. So the wavelength to go from one point of the wave and it's all the way to the next point on a wave, which is 20 centimetres. If 10 waves are produced in 5 seconds, calculate the frequency. So the frequency would be the waves divided by the time. So 2. 10 divided by 5. Use the equation wave speed equals wavelength times frequency to calculate the speed of the waves. So we have the frequency from a previous question, to highlight it, and then we have the wavelength from a previous question. So 20 times 2, 40, and then the unit is centimetres per second because the distance is in centimetres. Underline the correct statement in the bracket below. If the wave amplitude was doubled and the speed of the wave, would the speed of the waves double, stay the same, or half? And the answer would be stay the same. Question 3, Big Bang and redshift. Complete the sentences below. The universe began as a result of an explosion known as the Big Bang. The universe continues to expand away from the Big Bang. The evidence for the Big Bang is provided by redshift measurements. Cosmic microwave background radiation is the remains of energy produced by the Big Bang. The universe is estimated to be 13.5 thousand million years old. Light years are used when measuring the universe. What is a light year? Distance light travels in a year. And then the next question, theories about the universe have changed over time as more evidence has become available. Initially, the steady state theory was widely accepted. This believed the universe was not only homogeneous in space but also in time, i.e. it looked at the same at any place at any time. Explain how the detection of the cosmic microwave background radiation was a powerful blow against the steady state theory. So this first mark, the steady state theory is based on an unchanging universe, whereas the Big Bang is based on an expanding universe. So you get 1 mark for stating both of them. Cosmic microwave background radiation then is the remains of energy created in the Big Bang. And then gamma rays stretch to microwaves due to the expansion. So that's why then the waves get bigger as it goes to microwaves. Next question. Name and explain other evidence apart from CMBR that shows the universe continues to expand away from the Big Bang. So you've got a mark for stating redshift. That's our other piece of evidence. And it's caused due to the wavelength increase of light because galaxies are moving apart. Next question, there are many galaxies observable from Earth. Describe what observations tell us about the motion of distant galaxies compared to those closer to us. So remember with redshift, the further away the galaxy, the faster it moves away. Question 4, questions about the solar system. Complete the following sentence. The solar system is formed by the collapse of a cloud of gas and dust. The gas and dust could be either way round, doesn't matter. The table shows some information about planets in our solar system. Use information in the table to answer the questions that follow. Describe how the temperature of a planet depends on the distance from the sun. So we're just looking at the trends. So as the distance from the sun increases, the temperature decreases. Identify the planet that does not follow this trend. So if we're looking at temperature, it's here. The that doesn't follow the trend is Venus, because it doesn't decrease, it increases at Venus. Pallas is an asteroid found in the asteroid belt. Estimate its temperature. So the asteroid belt we know is found between Mars and Jupiter. So the asteroid belt belongs down here. So I can draw my pink line so you can see. So estimate its temperature. So I've just chose minus 100. You can have any value between minus 121 and minus 149, because anywhere between those two. Estimate the orbital time. So the orbital time here is 2 to 12. I've just chose 10, but you can have between 3 and 11. Can't have 2, because that's Mars. Can't have 12 because Jupiter. But you can have 3 all the way to 11, because it's in between Mars and Jupiter.